So we've worked on adding, subtracting, multiplying, simplifying different types of polynomials. So that leads us into then the next one, which is dividing polynomials. That's what we're going to spend today doing, dividing polynomials. And specifically, we're going to talk about using what we call synthetic division to divide different types of polynomials. There's really two ways you can divide polynomials. You can divide them using long division, or you can use synthetic division. Long division works well if you have something that's not linear. Actually, the only way you can do it if you have something that's not linear. But that's not what we're going to concern ourselves with too much in here. Everything we do, it's going to be kind of this linear piece of it. So when we're dividing polynomials, we're going to use kind of this shorthand method called synthetic division. Synthetic division is a method for dividing polynomials by binomials. So it's taking these longer things and dividing them by a binomial. Now, one thing about the binomial, synthetic division only works if what your divisor is in the form of x minus k. It has to be linear. So what we're dividing by has to be in the form x minus k, where k is just a number. It can't be x squared, it can't be x cubed. It has to be x minus k. So in the case that I have right here, my divisor here is x minus 2. So that's linear. And because it's linear, then that means that we're okay to do synthetic division with it. If you had something like 2x minus 2, that's okay. That we could use synthetic division. You can't use synthetic division if it's x squared or x cubed or the square root of. Then it just doesn't work. Okay? Now, synthetic division does a whole bunch of things. There's a remainder theorem. There's a factor theorem. We're going to talk about the factor theorem today. But being able to do the process of synthetic division leads us into other things. It leads us into factoring things. It leads us into figuring out if it's a zero or not. It leads us into, solving in some cases, or using what we call the remainder theorem. But there's a process to this synthetic division. So here's the process. If you have something that's in the form 2x, if you have like 2x cubed plus 5x squared minus x plus 7, and that's being divided by x minus 2, here's the process. The first thing you're going to do is you are going to take your divisor and not use a highlighter. You're going to take your divisor and set it equal to 0. So our divisor in this case is x minus 2. We're going to set that equal to 0 and we're going to solve. So we add 2 to both sides. So that gives me x is equal to 2. What we're going to do next is we're going to draw a little bit of a box here, and we're going to put that 2 inside of that box. And now we look at our polynomial. In this case, 2x cubed plus 5x squared minus x plus 7. And I'm going to note that we start with x cubed. That means that I have to have numbers for x squared, x, and our constant. This top part is just to help me understand and see that I have everything involved. And what I'm going to do underneath those is I'm just going to put the numbers that's associated with them. So with the x cubed, there's a 2. With the x squared, there's a 5. With the x, it's negative, so it's negative 1. And my constant is 7. we start with x cubed, there has to be an x squared and x and a constant. If one of them is not there, say the 5x squared wasn't there, we're going to fill it in with a 0. And we'll look at that in just a minute. But we have to go down the line. Okay, so continuing this process, the next thing we're going to do is we're going to draw a line. Leave some space. We are going to take this 2 and we're going to drop it straight down. And we're going to write that underneath the line. You always take that leading coefficient and you're going to drop that leading coefficient below the line. Then we are going to take the number that's inside of the box and the number that's underneath the line, and you're going to multiply them together. The result of multiplying them together is going to go above the line underneath the next one. So 2 times 2 is 4. So I've got a 4 right there. Now we're going to take that 5 and 4 and we're going to add them together. 4 plus 5 is 9, and that 9 is going to go below the line. Because it's below the line, I'm going to then multiply it by that 2 again. 9 times 2 is 18. So you multiply, goes above, the product goes above the line. When they're both above the line, you add them together to get the number that's below the line. So negative 1 plus 18 is 17. That 17 goes below the line. Now we're going to take 2 times 17. 2 times 17, it's a product. This product is 34. So that goes above the line. 7 plus 34 is 41. That 41, that is going to be my remainder. So now we have to write the solution. The solution for 2x cubed plus 5x squared minus x plus 7 divided by x minus 2. We're going to take this number. That's going to be our new leading coefficient. And we started with x to the third. We're going to take it down one exponent, so it's going to be 2x squared. And now we're just going to continue to write those two numbers. So we're going to go plus 9. And now we're just going to keep going down the line. So it's going to be 9x. 17 is going to be our constant at the end. We have to put the remainder in there. So here's what we do with the remainder. Because it's positive, we're going to put plus, and then we're going to put 41 over what our original divisor was, x minus 2. And this is the solution to our problem. 2x cubed plus 5x squared minus x plus 7 divided by x minus 2. Okay. So this synthetic division becomes about a process. Couple big time warnings you have to be careful about. 1, make sure you copy down the numbers correctly. Check the symbols. Check the signs. Okay? And then always double check your math. You're adding, going down. Multiplying to get the ball above the line. Make sure you check and double check your math to make sure you've got these correct. Okay. Let's look at another one where we'll do the process again. Written just a little bit differently this time. Essentially means the same thing. We've got 3x to the fourth minus 5x cubed plus 2x squared minus x plus 5. It's being divided by x plus 1. So again, step 1. take your divisor, x plus 1, set it equal to 0, and solve. So we get x equals -1. That -1 is what's going to go inside the box. Now, this next part I just like to do. You don't have to do this, but I just like to do this. It starts with 3x to the 4th. And then I just like to write down the x cubed, x squared, and c. I just like to write that down to make sure I know which ones have to be filled in. They all have to be there. It's -5x cubed, 2x squared, -x, and 5. So everything's there, so I'm okay. We don't have anything underneath the line. So we got to get something underneath the line. So we drop that 3 down. 3 is below the line. 3 times -1 is -3. They're above the line. So -5 plus -3. Below the line goes -8. -1 times -8 is 8. That product goes above the line. Add them together. 2 plus 8 is 10. So 10's below the line. -1 times 10 is -10. -1 plus -10, below the line's -11. Multiply again. -1 times -11 is 11. 5 plus 11 is 16. That's the last one. That's going to be my remainder. So now we write out the solution. Let's bring that 3 down. We started with x to the 4th. So we're going 1 less. So that's 3x cubed minus 8x squared plus 10x minus 11 with a remainder of positive 16 over x plus 1. That's our solution to it. Always double checking your math as you're doing these. Check your multiplying, check your adding, make sure you have the signs correct. Negative times a negative is a positive, negative times a positive is a negative, and so on and so forth. You have to be careful with these. Lots of silly little mistakes happen when we're doing synthetic division. Any questions with those two? All right, the next one. We've got 8x cubed plus 6x squared plus 7. Now that's being divided by x plus 2. So x plus 2 is my divisor. Set that equal to 0 and solve. So -2. Everybody sees how I got that part, right? Right, so I start out with 8x to the 3rd. That means I have to have x squared, x, and a constant. All of those things have to be filled in. I've got 6x squared. I don't have an x. So because I don't have an x, I still need something to fill its spot. And we're going to fill its spot with a 0. Because 0 times x is just 0, so I really haven't added anything in there. My constant is 7. And I had to do this because there wasn't an x in my problem. And you have to start out at the highest one that it goes through and all the way down to the constant. So we have to go 3, 2, 1, constant. We draw our line. Bring down the 8. Negative 16. That makes for negative 10. 20. And 20. 0 plus 20 is 20. Negative 40. Negative 33 is our remainder. Started out with x cubed. That's going to be 8x squared minus 10x plus 20 minus 33 over x plus 2. That should be the solution that you got. So what happens if we don't have one in there? Here's kind of something for your notes. If a polynomial is missing a term, polynomial is missing a term, fill it in with a 0. Anytime a polynomial is missing a term, fill it in with a 0. And we just start where the problem starts. Starts with x cubed, x squared, x in a constant. You don't go the other direction. Just go down, don't go up. Just go down. That would be bad. You'd just be adding a bunch of zeros in. All right, give this one a shot. See how you do. 3x to the 4th minus x cubed plus 5x minus 1 divided by x plus 2. See what you get. Okay, so before you get too far along, you should add 3, negative 1, 0, 5, and negative 1. Okay, go ahead, check your solution, see how you did. Any questions with that one? Any questions so far with dividing using synthetic division? far, so good. All right, so the next thing we want to talk about is we want to determine whether something is a factor of a polynomial. So we've worked with factoring, we've worked with quadratics. We did the X method, we said factor this. Well, we can factor polynomials as well. And we can use synthetic division to determine if something is a factor of a polynomial or not. The way we do that is we use what's called the factor theorem. Essentially what the factor theorem says is it says that, in this case, that binomial x minus 1 is going to be a factor of x cubed minus 4x squared minus 3x plus 6 if the remainder is 0. Okay? So we can essentially say that something is a factor of a polynomial if, when you do the synthetic division, you get a remainder of 0. Then we can write it as a product of two polynomials. So in this question it says determine whether this is a factor or not. So essentially what we're doing is we're taking x cubed minus 4x squared minus 3x plus 6. We're taking that and dividing it by x minus 1. And if we get a remainder of 0, then we say yes, x minus 1 is a factor. Okay, so if we're using synthetic division, what goes inside of the box? Positive 1 goes inside the box. X minus 1 equals 0, so positive 1. I've got 1x cubed, so that means I need an x squared, an x, and a constant. Looks like I've got them all. So I've got everything I need. I drop the 1 down underneath. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. Negative 3 plus negative 3 is negative 6. 1 times negative 6 is negative 6. And 6 plus negative 6 is 0. So my remainder in this is 0. So the answer, it says determine whether it's a factor. Yes, it is a factor. So if it's a factor, this is how we write it. We write our factor first. Our factor was x minus 1. Now we're just going to take this and write it how we have been. So we started with x cubed, so it's x squared minus 3x minus 6. Those two things make for your solution. The remainder needs to be 0. If the remainder is 0, then it's a factor. If your remainder isn't 0, it's not a factor. And then we just write it as the product of two factors. I'm going to change this question up a little bit. I want to know, is x minus 8 a factor of x cubed plus 3x minus 4? Go ahead and determine if x minus 8 is a factor of x cubed plus 3x minus 4. And if it is a factor, write it as a product. If not, just say no. What goes inside the box? 8. So we've got 1x cubed. We need to have an x squared, an x, and a constant. There's no x squared, so I have to put a 0. X is 3, constant is -4. I can already tell this is going to be bad. That's 8, that's 8, that's 64, that's 67. That's a big number. 67 times 7. Help. It's 8 times 67. 536. So we've got a remainder of 532. So is it a factor? No. It's not a factor. And then if it asks you if it's a factor or not, say no. It's not a factor. So what you're going to work on today is you're just going to work on the first 4 problems. Questions 1, 2, 3, and 4. That's it. You do not go beyond number 4. We're going to talk about the remainder theorem tomorrow, and we'll talk more about this factor tomorrow as well.